Well, in that last podcast, Mr. Sams, we learned about breaking things up.
We did.
And heating them up.
Yeah. Now let's do some math.
We should do some math. Everybody get your calculator out because you're going to do some mathematics. We did that all without math last time.
Yep.
And now we got to teach you the math.
Yep.
You say, there's math in science? Yeah, okay. Hey, before we do that, though, important thing, the graph. Have we seen this before?
I think we have.
Yeah, but we've got to add some more to it.
Yep.
So
let's put the equations on there.
there's some equations. Okay, remember we said there's heat it up and break it up.
Yeah.
All right, so actually when you do heat it up, there's actually the heated up equation.
That you've already seen.
Yeah, and this is Q is equal to mc delta T. And the break it up equation is a new one. It is Q is equal to delta H, we've seen that, times N. Now we'll have to define what those N's are in just a minute. All right, so where's heated up, Mr. Sam?
Heated up is when there is a temperature increase, so
that's
A, C, and
E. So during the heated up portions, I like to sometimes just do like a slash line. That means they're going up, right?
Yep.
And the break it up are the flat portions of the graph. So heated up, so this is going to be, you're going to use MC delta T here.
Mm-hmm.
During part B, you're going to do delta H times M. N. I'm not going to write the Q. That same thing, because that's always equals that.
Yep.
MC delta T here, delta H times N, and MC delta T. So you should copy this down, and you'll see how we use that as we do the math problem.
One thing, should we throw the units on here? Talk about what your units come out as, because you do have to do a little bit of a conversion.
Yeah, that's an important thing. Actually, let's break this out here. Okay. So let's just take a look at these, Mr. Sams, about what they are. So we've got Q equals MC delta T. So what's M stand for?
That's our mass.
So that's going to be in units of?
Grams.
C is the specific heat, and that's joules per gram degree Celsius. You might remember that the most common one that we work with is the specific heat of water, which is 4.18.
And that's liquid water, we should point out.
Yeah, that's true.
Because ice and steam have different specific heats than liquid water.
And delta T is the change in temperature.
So that'll be in degrees Celsius.
In degrees Celsius. Now, Q, when we get this, will give us a joule answer.
Yes.
All right, that's important. Okay. Now let's take a look at the break it up equation, which is Q equals delta. Delta H.
Oh, I see what you're doing. Yep.
Times N. All right. Now delta H. These are the ones we talked about in the previous podcast: the heat of fusion, the heat of solidification, etc.
And those are all kilojoules per mole.
So those are in kilojoules per mole. Okay, that's weird. And N is something we haven't seen before.
N is moles.
That's moles. That's the symbol for moles. So if you've got so many grams of something, you just convert it to moles.
Yeah.
So the Q is going to be in kilojoules. So what we're going to oftentimes do is going to add these numbers up.
Right, but
the two Qs.
You can't add a joule to a kilojoule.
Yeah, it's kind of like saying I got $5 and you got 2 cents. So do I have $7?
No.
I have $5.02,
right.
don't I? So you can't add in the same unit, or you have to add in the same units.
So we're going to have to either convert joules to kilojoules or convert kilojoules to joules.
I recommend that you convert everything to kilojoules.
Yep.
It's a little easier. The numbers tend to be smaller and easier to manage. Okay, let's do an example. Example 1.
Okay.
Okay, how much energy does it take to warm up 25 grams of water from 4.5 degrees to 56?
All right, can we throw that on the graph and kind of see where?
I think it's important to always start with that. Now this is water, and so for water, if I'm at 4.5 degrees, that would be about right here.
Yep.
And I'm going to go to what temperature?
40. I don't remember. 56.7.
56. So 56. I'm going to go here to here. So guess what? I'm only going to go through, well, it's a heated up deal.
Right. So the only thing we have to do here is Q equals MC delta T.
This is an easy problem, Mr. Sams. So Q is equal to MC delta T. So the mass is
25 grams.
25 grams. Now this is water. So this is 4.18 joules per gram degree Celsius times my change in temperature. It looks like 52.2.
I don't know. I'm just putting it in parentheses and punching it in.
It's 52.2.
5455 is our answer.
5,455 55 joules. And if I would just quickly convert that to kilojoules, that's 5.5 kilojoules.
Okay.
So that's not too bad. That's how much energy it takes to heat that water up.
Okay.
Okay, let's do that. That's not too bad.
All right.
All right, let's do example number 2. How much energy does it take to melt 56.7 grams of water at its freezing point?
Okay, so this...
All right, let's look at the graph.
Okay, let's do it.
So if I'm at its freezing point, it's still water, working
Right.
with water.
That's B.
Well, I'm starting here. It's melted. It's frozen.
Right.
Frozen ice, and I want to just melt it.
Right. So we don't have any temperature change.
So we're just going to use the break it
We're
up
just
equation.
going to break it up. So Q equals delta H times N.
So Q is equal to delta H. Now, actually, delta H
Fusion.
FUS
Yeah.
times N.
Okay.
Now, we got to find what N is, though, because we have 56.7 grams of
Right.
water.
So we're gonna have to do a little conversion.
56.7 grams over 1. And this is water, so I'm not putting the... I'm going to say grams to 1 mole. This is just grams a molar. And it's water, of course, H2O, so that's 18 grams in a mole. So how many moles do I have?
That's 3.15 moles.
3.15 moles. Now, we didn't put this on the table, but you might remember the delta H fusion was 6 kilojoules per mole.
One significant figure.
6.02.
I think it's 6.01 or
I think it's
something like
0.01.
that.
It is, let's say 1. So you're
We'll
just going to
check
say 6.01 kilojoules per mole. Notice how I'm writing this so it's easier to see how things cancel. Times 3.15 moles. It's really over 1 if you think about it. The moles cancel and you get like
18.9 kilojoules.
18.9 kilojoules.
Okay.
That's pretty easy.
Yeah.
All right.
I have a hunch we're going to stick those two together next.
I have a thinking. All right. All right. Example 3. Let's make it hard.
All right.
How much does it take to warm up 25 grams of water from negative 20 to water at 60 degrees?
Grams of ice at negative 20, I guess
Oh,
it
yeah.
would be. All right, so let's
Well,
put that on the graph. Negative 20.
Negative 20. So I'm starting here at negative 20. So I'm X right there.
Okay, up to 60.
And we're going up to 60. 60 is here. Oh my gosh. I got 3 stages, Mr. Sams. I'm going to go from, I have to heat up
Heat
the
it up.
ice. I have to break
it
up
up.
the ice, and I have to heat
Heat
up
it
the
up again.
liquid water.
Yeah.
So we're going to have 3 problems, and we have to add them together.
Okay.
This is tricky. All right, when we're doing this problem, Mr. Sams, what I like to do is I like to kind of map it out. I need to first go from negative 20 degrees as a solid to 0 degrees as a solid.
Now, why'd you stop at 0?
Because if you look at my graph that we have right here, I need to stop whenever I get a change in the direction
Okay.
of the curve.
Okay.
So I have to stop at 0 because that's the temperature it stops at. And that is a heated up equation, so I'm going to say MC delta T. I'm not going to say the Q because that's what we're solving for.
Okay.
So the mass was 25 grams times the specific heat. Now, an important thing that's not on
Specific
here,
heat of ice.
the specific heat of ice is not the same as the specific heat of water.
Nope.
Now, we have this in your packet in a table, and I believe
Yeah,
it's
2.09.
So the specific heat of ice is 2.09 joules per gram degrees Celsius, not 4.18, about half. In fact, exactly half, I guess. And the change in temperature from negative 20 to 20 is 20 degrees. So when we multiply that out, we get a total number of joules, 25 times 2.09 times 20, we get
1,045.
1,045 joules.
Joules,
Now,
or-
I'm going to quickly convert that to kilojoules
Yeah.
because it's easier to add later on. So that'll be 1.0 kilojoules.
All right.
Then I'm going to go from 0 degrees as a solid to 0 degrees as a liquid. So if you
That's
go
a
back,
break it up.
That's a break it up. So if you go back here, I'm going just from here to here before the next bend takes place. And that's a break it up equation. So that's going to be delta H fusion times N. And that's going to be
Heat fusion's-
25 grams. And you know what we didn't do?
We need
find
to
the
convert that
moles.
into moles.
So if I have, I'll do it up here top here, 25 grams over 1, 18 grams in 1 mole. 1 point something, Mr. Sanders.
8.35.
No, that's not
Oh,
right.
that's the final answer. Sorry. Getting ahead of myself. 1.39.
1.4 moles. So this is 1.4 moles.
I'm going to get your 25 grams out of there.
Oh yeah, 1.4 moles times,
6.01.
this is 6.01
which is our delta H of fusion.
kilojoules per mole. So times 1.4, was it like 8 or something?
8.35.
8.35. That's in
8.4.
kilojoules.
Right. Yeah.
So here we have this number and this number.
Okay.
But I'm not done yet.
Nope,
I still
one more
have to
step.
go from 20 degrees.
Nope, from 0 degrees.
Pardon me, from 0 degrees as a liquid to 60 degrees as a liquid. And that's going to be heated up, so MC delta T. So now we are going to use 25 grams. And this is liquid water, so I use the number I'm familiar with, 4.18 joules per gram degrees Celsius, times the change in temperature, which is 60 degrees from 0 to 60. And you get what, Mr.
6,270 joules.
6270 joules, which is 6.3 kilojoules. Now, I now need to add my kilojoule numbers up. These three numbers here. And what do you get, Mr. Sams?
15.7.
So the answer is the sum of them, so it would be 15.7 kilojoules. So that means to take 25 grams of water from here to here to here, it takes
15.7 kilojoules.
15.7 kilojoules. Okay?
All right.